Recording. All right, so welcome everyone to this class. In this class, we'll be solving questions from tutorial sheet 3, which is the tutorial sheet on functions. So, okay, so we expect to solve different questions, okay, on different concepts, but under the topic what? Functions. Okay, so if you have any questions on whatever I'm going to be explaining, please feel free to ask. Okay, I'm not a lecturer, I'm just a tutor. So feel free with me, okay? Ask. If you're not understanding, ask, and then I'll try to explain again and again until all of us are on the same page, okay? So I know your mid-semester exams are fast approaching. Okay, I was looking at a timetable the other day. So what you're required to do for you to pass that mid-semester exam is be familiar with the class notes that Mr. Chipoka sends. Okay, make sure you go through all those class notes. Where you do not understand, you can ask anyone to help you. You can even ask me. Okay, and then two, make sure that you solve all the questions in the tutorial sheets. Okay, so I can guarantee you, as long as you're able to solve all the questions in the tutorial sheets, okay, you're going to pass your mid-semester exams. Because sometimes what they do, they'll just get the same questions that were in the tutorial sheets, and then they bring it in the mid-semester exam. Okay, so if you're able to solve all the questions in all the tutorial sheet that you've been given, then it will be very easy for you to answer the questions in that exam. Okay, so far I've seen like 5 tutorial sheets. So make sure you practice frequently. Okay, solve questions from those tutorial sheets, read those notes that he sends, then you'll be good to go. Okay, so today we'll be looking at questions on functions. Okay, but before we even look at questions, okay, I feel it is important to explain some of these concepts. Okay, so a function is under the umbrella of what we call as a relation. Okay, so we know a relation. Okay, this relation is just it's just simply a relationship between two sets. Okay, so we can have maybe a set A, okay, here, and then we have a set B there. So how the elements of this set A are going to be relating with the elements of set B, that's what we call as a what? A relation. Okay, so we can have maybe 1 here, 2, and then 3, and then they're being marked to 2, 4, and then let's say 6. Okay, so this one will go to 2, this 2 will go to 4, this 3 will go to what? To 6. So we know that we see that there's some kind of relationship between this set and that set. Okay, so if these values here are x and these are y, the relationship here will just be y is equals to 2x. Okay, so if x is 1, y should be 2. Just put the 1 there. Okay, if the x is 2, you put it there, you get your y as 4. If your x is 3, you put it there, you get your y as what? 6. So a relation is just some kind of relationship, okay, between ordered pairs, like as you have seen here from set A to set B. So we have different types of relations, okay? So I know you know 4 of them, okay, because that's what you did at grade 12, okay? So we have a one-to-one relation, okay? Like the one I'm just from erasing here, that was a one-to-one relation. We have a one-to-many, okay? We have a many-to-one, okay? And then we have a many-to-many. So these are like 4 types of what? Relations, okay? So of these 4 types of relations, some of them are special relations, okay? And those special relations are the ones that we are going to be calling as what? Functions. Okay, so in a one-to-one, you just have, if this is x, this is y, you just have one element being mapped to 1 like that, okay? In a one-to-many, you have something like this. So I have my x's here, my y there, okay? You have one-to-many. So it means if this is the first element in set X, it's been mapped to maybe 1 and then 2. So we can see that 1 to many things in the other set here. Okay, so that's the type of relation that we have here. And then we also have a many-to-one. Okay, so many-to-one will just be like the opposite of this. So I have 2 points maybe here or 2 elements that have been mapped to the same guy like that. We're going to say this here is a many-to-one. And then the many-to-many, I'm sure you can guess what it's going to look like. Okay, so we have maybe 2 mapping to 1. okay? And then 1 here mapping to 2 like that. So we can see that this is a mixture of a one-to-many when we consider this one here, okay? And then when we consider this one, it will be a many-to-one. So when we combine them, they give us what? Many-to-many. Okay, so now I said from these relations, I mean, you're going to get something very special that we call as a function. So now what is a function by definition? Okay, so a function is a special type of relation where each input, okay, each input in the first set is assigned to exactly one output, okay, in the second set. So each input in the first set should have exactly one image, okay? So if we consider a one-to-one, are we going to say this one here is a function? Yes, we're going to say this one, yes, is a function. So why is it a function? Because each input here, okay, is being mapped to exactly one output there. Okay, and then here I have a one-to-many. So is this a function here? Okay, is that a function here? Anyone who can try. Is a one-to-many a function based on the definition of a function that I gave? Is it a function? A many to one? Okay, so based on the definition that I gave, this one here, we're going to say no, it's not a function because here I have one output being mapped to two different outputs like that. But by definition, we said that a function, okay, we said that a function is a type of relation where each input here should be mapped to exactly one output. But we see that this is one output being mapped to what? To two. So this one we are going to say it's not a function. Okay, what about this one? A many to one. Is it a function? Okay, so a many to one, yes, it's a function because each input here is being mapped to only one output here. The output might be the same for this one and this one, but if we consider just this one, we see that it's been mapped to only one. We consider this one is being mapped to only one. Okay, so we're going to say this here, yes, it's a function because each input here only has one image there. Okay, and then a many to many, definitely this one is not a function. So you see that out of these four types of relation, the ones that are function are one to one, okay, and the many to one. Okay, so I should emphasize again, a function is a relation where each input has exactly one output, okay? That's a function. So we're going to be using this concept here that I was explaining here to solve these questions on question what one, question 1A. Okay. So if you have any questions, please feel free to ask. Okay. So I'll erase this. So just unmute your mic and then you can ask. Don't type in the chat box. I'm not able to see the chat box here. Okay. So let's read the question here now and try to answer. So they're saying, with the aid of a mapping diagram, okay, where X denotes the input elements and Y the output elements, determine which of the following functions, okay, determine which of the following are functions and which ones are not. Okay, so we start with the first one. So the first one is Y is equals to uh, X squared. So they said with the help of a mapping diagram here. So I'm going to draw a set here, X. Okay, I'm going to say this is my X. And then in this X, I'm just going to pick some random variables that I can, random numbers that I can put there. Okay, so I'll say maybe -2, -1, 0, 1, and 2. So this is my set X. And then I'll need to find my set Y now using this relationship here. Okay, so here I'm using this relationship. So Y is equals to X squared. So my X is -2. What will be my Y? Okay, my Y will just be -2 and then squared according to this, right? So this will be 4. And then if I put -1 here squared, okay, that will just give me what? A 1. Okay, and then if I put 0 here to just give me 0. If I put 1 to give me back a 1, okay, so there I have to map it like this. So this 0, okay, let me show this properly. Okay, so this 0 was being mapped to what? To a 0. So it's like this. Okay, and then 1 is being mapped to 1 again. And then 2, if I put 2 there, it will be mapped to that 4 again. Okay, so here we see that this relation is what? Is actually a many to many. Okay, a many to one, I mean. Okay, because I have these two the -1 and the 1 mapping to 1. So that is many to 1. I have the -2 and the +2 mapping to 4. So that's also many to 1. So many to 1 was considered as a function here. Remember, we said it is a function. Or if you want, you can forget about this. Okay, you can just look at the function that you have. So you make sure that each input that you put here only has one output. So this one is only mapped to the 4. This one is only mapped to the 1. The 0 is mapped to the 0. The 1 is mapped to 1 again, which is just one output. They can be the same output, but we're just considering if I am here, where is it mapped to? It just maps to the 1. Okay, if I'm here on 2, where is it mapped to? It's just mapped to the 4. So this one here, we're going to say yes. Okay, based on this, we have a many to 1 relation. And the many to 1 relation, okay, we have discussed that it's a what? It's a function. Okay, so any question on the first one that we have done here? Any questions there? Okay, so if there are no questions, sometimes, I don't know if you've learned that concept. Okay, you can also tell if a function is, if a relation is one-to-one by just using the vertical line test. So the vertical line test requires that you know how to sketch these different types of functions. Okay, so the function that we have here is y is equals to x squared. So that's the quadratic equation that is that has a vertex at the origin here. So this is y is equals to x squared. And then from this graph, you can tell, okay, if it's a function or not. So how do you do that? You use a vertical line test. So you just come on this graph and then draw a vertical line anywhere. Okay, draw a vertical line anywhere that you want. And then you ask yourself, how many points does this vertical line touch this curve that you have drawn? Okay, so if it touches only at one point like that, then you know that it is a function. Okay, I'm going to show you another example. If we draw a vertical line, you see that we have 2 points where this vertical line will touch. So that will not be a function. Okay, so this will mean that uh, yes, it's a function because why? It only touches this curve at one point like that. When you draw a vertical line anywhere here, this vertical line will just touch here, anywhere there to just touch there. Okay, so any questions there, guys, before we move to 2?
I don't understand how you explain the first part where you
Um,
drew the X and the Y.
okay, can you come again? I didn't get the question.
I haven't understood your first solution.
This one here.
Yes.
Okay, so there they said we use mapping diagrams, right? So we're just getting arbitrary points. Okay, you can literally pick any points that you want. Okay, so the relation that we're using is y is equals to x squared. This one, you've seen it, right? So here they told us that the X denotes the inputs and then Y are the outputs, right? So for the inputs, we're just going to come up with some numbers, okay? And then from those numbers, we are going to get the output. So the number that we came up with was, the first one was -2, -1, 0, 1, and then 2. So these ones here, you just come up with them. It's you to come up with them, okay? You can literally pick any points. And then now you start using this relation. Okay, so we're going to say this is set X here. Start using this relation to find the values of Y. Okay, so how are we going to do that? For the -2, we're going to say Y is equals to, when X is -2, what is Y? Okay, so where there's X here, I'll put -2. So this will be 4. So this 2 here, the -2, it means to be mapped to 4. Okay, so in fact, you should write the Y values in order here. I didn't write them in order on the other part. So we had the 0, 1, and 4, right? So if I square this, I get 4. So I go like that. Okay, if I square 1, I'm getting 1. If I square 0, I'm getting 0. If I square 1, I'm getting 1 again. If I square 2, I'm getting 4. So now you have this mapping that you have. Okay, so you ask yourself, on the 4 types of mappings that we had earlier, okay, where does this one belong, or where does this one fall? Okay, we see that we have many points here. I have these 2, -2, and the +2. They're both mapping to the 4. Okay, so these are many to 1. So this relation is many to 1. And we say that the many to 1 is indeed a what? A function. When we are just starting, I don't know if you are there. Okay, or you can forget about this and then just check the output of each element. So make sure that each input value that you put here on the set X has only one output. So if I consider these 2 here, how many output does it have? It only has these 4. Okay, if I consider the -1, 1. If I consider the 0, 0. If I consider the 1, 1. If I consider the 2, 4. So we see that each of these x input values here has a unique output value here. And then we conclude that yes, it's a function. Okay. I don't know. Have you understood now?
Yes, thank you.
All right. Amazing. Okay. So now we look at question 2. Okay. So we get familiar with the concepts. So let's look at the part 2 there. So part 2 here is the root of x. Okay, so we know that we can't have a square root of a negative number. So it means the values of x that we pick here should be strategic. Okay, they should be the values that start at 0 and going above. Because if we pick x as maybe -4, there's no root for -4. Okay, so on our x values, we're going to say the first one we pick 0 and then 1. Okay, we can pick 4 and then 9. So you see that I'm being strategic in the x values that I'm picking here because I don't want to pick any that will give me a decimal number here. Okay, I'm just picking the numbers that I know they will give me a perfect square root here. Okay, so what will it be here? Okay, so here, the relation that we are using is y is equals to the root of x. So if my x is 0, what would be my y? To just be y is equals to the root of 0. Root of 0 is 0. So I'll put 0 here. If my x is 1, what would be my y? Okay, to just be 1. If my x is 4, what would be my y? The square root of 4 is what? 2. If my x is 9, okay, what would be the root of 9? To just be 3. Okay, and then you ask yourself now, what type of function is this? This function is just one-to-one. We see that each of these um, input values, they're being mapped to only one. Okay, so we're going to conclude that yes, okay, this one here, number 2, it's actually a function. Okay, and then if you want to use the vertical line test, later on you know how to sketch all these things. So this one, y is equals to the root of x. It's a graph that goes like this. Okay, so if I draw a vertical line on any point here, you see that this vertical line will just be touching this curve here at one point like that. So we're going to conclude that yes, it's a what? It's a function. Okay, so any questions there? I hope this one is simpler. Any questions there? Okay, so if there are no questions, let's look at this one here. So now this one is a very interesting question here because the equation that we've been given there is actually the equation of a circle. Okay, so you're going to see that a circle is actually not a function. Okay, so we have x squared plus y squared is equals to 9. Okay, so let's make uh, y the subject, or if you want, you can just leave it like that. Okay, so now here on picking the x values, I'm going to be very strategic. Okay, so I can see that my y is y squared. Okay, so it means to find the value of y, I'll have to be square rooting. Okay, because if I make it the subject here, it will be something like this, to be y squared is equals to 9, and then this x squared goes to the other side, so it is minus x squared. And then I want to find the value of y, right? So I'll square root both sides here. So if I square root where the y squared is, I just end up with the y is equals to. If I square root this side, I'll have plus or minus the root of 9 minus x squared. So we see here that for each value of x, I'm going to have two values of y because one will be positive, the other one will be negative. So already that tells me that this is not a function, okay? But I want to show it using what? The mapping diagram here. So for the x values, I'm going to pick um, 0, okay, 5, and 9. Okay, so I'm very strategic on how I'm picking these values. So this is my set x, okay? And then I'm going to be using this relation here, or simply this relation here, to find the values of what? Y here. This is my y, okay? So remember my y is given by this equation. So if my x is 0, then it will be y is equals to plus or minus the root of 9, because the x squared there will just be 0. So what is the root of 9? So plus or minus root of 9 is 3. So it means this 0 here will be mapped to two values, okay? Plus 3 and minus 3. Okay. What if my x is 5? If my x is 5, what am I going to have? Okay, so here I should have picked 2 and not 5. Okay, because 5 will cause problems. So I should have picked 2 here. And then on the other one, I should have picked 3. Okay, I didn't see the square there. So if my x is 2, then I'll have something like y is equals to plus or minus the root of 9 minus 2 squared. Okay, so this will be what? To be plus or minus root of, um, this will be 9 minus 4. So 9 minus 4 is just 5. Okay, so it means if my x is 2, my y can either be, okay, plus root 5 or minus root 5. What if my y is 3 here? Okay, I mean if my x is 3, I'll have plus or minus root of 9 and then minus 3 squared. So this gives me what? Plus or minus, this one here will give me 9 minus 9. So this will just be 0. Okay, so my y will just actually here, it will just be 0. Don't follow the signs here. So the things that I have here, it is minus 3 minus root of 5. Okay, and then I have 0, and then I have 3. In fact, I should have root of 5 there, and then 3 like that. Okay, then I can do my mapping now. So this 0 maps to two things. Okay, when my x is 0, remember we found our positive 3 or minus 3, like that. Okay, if my x is 2, we said we are going to find plus root 5 or minus root 5. So I'll go to minus root 5 and positive root 5, like that. And then if my x is 0, I mean if my x is 3, I'm just going to 0 like that. So now you ask yourself, what kind of um, relation am I having here? So we see here that I have one output here, this is 0, okay, being mapped to two different things. So that is one to many, okay? And in our introduction, we said one to many is never a function. So we're going to say no, it's not a function. Or if you want, you don't use that, you just use the same mapping that you have. You go at 0 here, okay? Because we said the function, okay, for each x input, it should have a unique y output. But this x value input here, okay, the x value input here, you see that it has it is being mapped to minus 3, and it's also being mapped to what? To 3. So it has two outputs like that. Okay, so the outputs are not unique. So we're going to conclude that what? This guy here is not a function. Okay, so the circle here is not a function. And you can also show it on a graph. Okay, so if there are any questions, please ask. So on a graph, a circle looks something like this. Okay, so this is a circle. Um, x squared plus y squared is equals to 9. So the radius here is 3 minus 3 minus 3, 3. So how do you get the radius? You just square root the 9 there. Okay, so this is the graph of this function here. So now notice that when I draw a vertical line, it's going to touch this curve at 2 points. It's touching there and it's touching there. Okay, even if I draw it here, it will touch there and it will touch there. I draw it there, it will touch there and it will touch there. So the vertical line is touching the curve at 2 points. Okay, so that simply means that um, the curve that I've drawn, okay, or whatever it is, it's not a what? It's not a function. Okay, so any questions there? Any questions there, guys? Okay, are you understanding? All right, so if you're understanding, then I'm happy. Okay, so let's try to look at the other one there. Okay, so if you have any question, please feel free to ask. Let's try to look at this other one there, the number 4. So number 4, I can see that that is a function there. Okay, just by looking at it. So this is y is equals to the modulus of x. So these bars here, or we call them modulus, they simply mean whatever value of x that we have there, either positive, negative, the output should be a positive value. Okay, so it's the same as x squared in some way. Okay, but its graph is going to differ. This one will have a sharp 10, and then this one here, the x squared has a smooth 10. So here I can literally pick any value of x that I want. So I'm going to say my set x here. Okay, my set x here can be anything. So I can just say minus 2, minus 1, 0, 1, 2. Okay, and then what will be my set y here? So my set y, it will be based on this equation here. Okay, so this equation we said if it has bar, then it's just making whatever is negative to be positive. Okay, so we will still have the same numbers. So it will just be 0, 1, and 2. So what we have is that this 2 is going to map to 2. Even this 2 here is going to map to this same 2. Okay, this one is going to be mapped to 1. the minus 1. And then the positive 1 is also going to map to this one. Then the 0 is going to map to the 0. Okay. So on the type of relations there, we said that this one, okay, if I consider this out, if I consider this input and this one, we see that they've been mapped to the same output like that. Okay. So this is a many to one. Okay. So he said many to one. Yes, it's a what? It's a function. A many to one is a function. Or if you don't want to consider that, just look at your mapping. Okay. I come at minus two here. Where is it mapped? It's only mapped to the 2. Okay. I come at minus 1. Where is it mapped? Only to the 1. 0, only to the 0. 1, only to the 1. Okay. So the outputs can be the same for different x element, but as long as that x element is just being mapped to 1, okay, we call it as a function. So this is a function. Okay. So when we draw that curve on the x or y plane, this is my y, this is my x, it will be a v on the origin like this. Okay, so it will have a sharp 10 on the origin. So if you draw a vertical line anywhere, there, you see that this vertical line will be touching these things only at one point, like that. Okay, so we're going to say yes. This confirms that indeed this is a what? A function. Okay, so I'll do the last one, and then the other one, maybe I can leave it for you guys to try. Okay, and then if you have any questions, feel free to inbox me. Okay, so let's look at question 5. Okay, so question 5, I can already see that it's not a function, but haven't been solved. Okay, so y squared is equals to x. So this simply means what? Okay, so this simply means for any x value, I'm going to have two y values, and that won't be a function. Okay, so how am I doing that? I'm making y to be the subject. So if I make y to be the subject, I'll square root this side. I'll just get y is equals to. If I square root this side, I'm going to get plus or minus the root of x. Okay, so now we can pick the values of x in a very strategic manner. Okay, because the root of x, they'll only take non-negative values. So like 0, 4, and maybe 9. Okay, and then here, I'm going to have my set of y values. So y values will be depending on this equation here. So if my x is 0, then I'll definitely have a 0, 0 there. Okay. If my x is 4, I'll have plus or minus the root of 4, which will be plus or minus 2. Okay. If my x is 4. If my x is 9, I'll have plus or minus what? 3. So what I have in this set is minus 3, minus 2, 0, 2, and then 3. So now I can draw my mapping. So this 0 goes to the 0. Okay. The 4 goes to the minus 2 and the positive 2. Okay. So it goes there and then it also goes there. Okay. We see that this one already defies the law of a function because it's one input having two different outputs. Okay. The 9 will go to minus 3 and to the 3. Even this guy defies it. Okay. So we see that this one here won't be a function. So we say no based on the mapping here. So these are the y values. Okay. If you want to show it on the graph, okay, the graph of y squared is equals to x. It's just a quadratic equation that opens in the positive x like that. Okay, so this one here is y squared is equals to x. So if we draw a vertical line anywhere here, we see that this vertical line will cut this guy at 2 points like that. Okay, so we're going to conclude that that one is not a function. Okay, so Natasha, you've raised the hand. You can ask. I've seen you've raised the hand. Or is it a mistake? Okay, so someone is saying, why did you say root x? Okay, so here I was just trying to make y the subject of the formula. So what we were given here is this. Okay, so uh, when we're dealing with functions at your level, okay, you always make y to be the subject. Okay, so that's what I was doing here. So how do we make this y to be the subject? I square root this side, this square root and the square will cancel, so I only remain with the y. Okay, and then when I square root the other side, okay, because it doesn't have any square on the other side and I'm just introducing the root, okay, then I have to put plus or minus, okay, plus or minus, because I know that if I get minus 3, I square it, it's going to give me 9. If I get positive 3, I square it, it's still going to give me 9. Okay, so the square root there should have two values. So that's where we're getting this root of x there. Okay, so any questions there?
So, for the graph method, how are you knowing what graph to use, like to draw?
Oh, okay, okay. Okay, so I was saying, I don't know if, have you guys learned how to sketch the graphs? Have you learned how to sketch so far?
Um, yes, we have.
You have? Okay, so if you have, okay, there are different ways of sketching. Like a quadratic function, you just have to know the turning point uh, and y-intercept. So that's what I used to sketch this one here. Okay, and then for this one is what we call the radical function. Okay, so a radical function, this is a standard radical function here with no shift, no vertical, no horizontal shift. So how do you sketch it? Okay, you just do this. It will start at x 0, y 0. So 0, comma 0 to start at here and then to go to the right. So this is a standard. Okay, whenever you see this, just draw something like this. And then for the circle, you just have to find the radius. Okay, and then you draw a circle around that radius. So for the radius, this one, I said for you to find the radius, you just square root whatever is the number on the right hand side. So here the radius would be the root of 9, which gave me a 3. So it means you from the origin you go to the right 3 times, you go to the left 3 times, you go up 3 times, you go down 3 times. So that forms the circle that I drew. So I drew something like this, right? Like that. And then I said this was 3 minus 3, 3 minus 3 again, and then 3. So these two my 3 is here, just the radius to the right, to the left, up, and then down. Okay, that's how I drew this. And then this one, it's just it's a modulus function. So how do you sketch a modulus function? Okay, just sketch it normally, and then you reflect whatever will be in the negative. So x is equals to y is equals to x is a graph that goes like this. Okay, so I think the meeting will cut. So if you to cut, just join in using the same link. We're still solving the other questions. So y is equals to x is something like this because it will just be plotted along the equal points. So 1, comma 1, you plot it 2, comma 2, 3, comma 3, you're going to have something like this. And then since we have modulus, we're going to reflect what is below the x-axis. So it goes like that. So no wonder I draw that graph here. And then this one is a quadratic equation, okay? But that has been inverted. It's now in the y-axis, okay? So it's a similar concept that you had here, but now here you're just getting like you're getting the opposite of what you did. Okay, so let's continue now. We go to question 2. Okay, so question 2 again, uh, it's on graphing quadratic equation, okay? But this method that we are using here on graphing this quadratic equation, okay, it's a very typical way of graphing things, okay? Because they are telling us to use um, a table of values. Okay, so it's a very typical way of sketching a quadratic function. So I remember we had a class where I was teaching you guys how to complete the square. And then from the completed the square form of a quadratic function, okay, I showed you how you can get the turning point, okay, and how you can get the y-intercept, the x-intercept, and actually sketch the quadratic function, right? Okay, so that method that we are using there, it's not accurate. It just gives a rough sketch, okay? Because we don't know the exact point where the graph will be touching, okay? For example, if I draw something like this, and then I draw a quadratic function like that, okay? So if you're using that method that we did there, the completing the square, you only have to find this point, this point, this point, and then you connect them with a smooth curve like that, okay? So it's not accurate because you do not know exactly the points where you are plotting, okay? But this one here, which I'm calling typical, it will be very exact. Okay, it will be very like perfect to what it's supposed to be because we'll be using the points. So we'll be plotting a set of points, and then along that set of points there, we're going to be putting a curve around them to draw the quadratic function. Okay, so that's what we are going to be doing here. So before that, okay, all these quadratic equation here have been expressed in what we call as the completed the square form or the quadratic form in simple terms. So the quadratic forms says if I have y is equals to, okay, a, and then x minus h, okay, squared, and then plus k. Okay, so this is the completed square form. So all these equations that you can see here have been expressed in this form. So from this form, we can get the turning point very easily. Okay, so how do you get the turning point? You get whatever is in the brackets here, you equate to 0 and then you solve for x. So in this case, we are going to say x minus h is equals to 0, and then x is equals to what? H. So this will be like h comma, okay? And then the y coordinate of the turning point will just be whatever is outside it here, which is not part of this first expression. So it will just be k. So the turning point will be k there, okay? So on all these equations, we're first going to be identifying the turning point. Then once we identify the point, turning points, okay, we're going to pick a set of values, okay, that we're going to put in a table. And then from those set of values, we're going to sketch the quadratic function. Okay, so that's what we're going to do there. Okay, so let's do that. Okay, so we start with the first one, or maybe we read the question. So the question, they're saying, using a table of values you've seen here, sketch each of the following quadratic functions. For each sketch, state the domains and the range for which the function is restricted to become one-to-one. Okay, so they've also brought in the concept of a one-to-one function here. Okay, so remember when we are doing for the function, we said we use the vertical line test, right? Okay, so now to check if a function is one-to-one and you want to use the graph, you use what we call as the horizontal line test. So like for example, a quadratic function like this. So you just draw a horizontal line anywhere. If it touches this curve at 2 points, then we know that this here is not one-to-one. Okay, it's not one-to-one. If you have this one here, okay, we have a vertical line like this to just touch at 1 point, we know that this one here is indeed a one-to-one. Okay, so now for some functions like these quadratic functions here, the quadratic function is never a one-to-one function. Okay, so for you to make it one-to-one, you have to restrict the domain. Okay, you have to restrict the domain because the way it is here, the domain is that here this graph goes to minus infinity. Here this graph goes to positive infinity. So the domain is the set of all real numbers. So you can actually restrict the domain so that your function can be one-to-one. So what do you think we should do? We should just cut this quadratic equation into two parts. So to start from there and then to go there. So this part here, just this one, starting from here, going this one, it will be one-to-one because if I draw any horizontal line, it's going to be touching this curve at only 1 point. Okay. So what I've done here is restrict the domain. So we're just being I will just be considering the domain from minus infinity all the way to the x value that is here, which is 0. Okay. Or we can restrict it using this side. We can just say from 0 all the way to positive infinity. So we have restricted the domain. It means all this curve here will be what? One-to-one. So that's exactly what we'll be doing here. So now let's look at question 1 there. Okay, so if you have any questions, please ask, guys. So let's look at question 1 there. So question 1 here, okay, we have y is equals to x squared plus 2. Okay, so what I'll do, I'll make this look like this standard form here. So what am I going to do? I'll say y is equals to, okay, I'll say 1, open brackets. I want to make this x squared look like this. So I'll just say x minus 0 squared, okay, and then plus 2. So you can see that we have our a, okay, we have our a, our h, and our k just here. So this is our a, this is our h, this is our k. So it means what is the turning point here? Okay, so the turning point, I just equate this x minus 0 to 0. So for x, it will just be 0, comma, and then the y is whatever is outside there. So it will just be 2. Okay, so my turning point is 0, comma 2. So once I find my turning point now, I'll just pick some random values. Okay, I'll just pick some random values. Preferably, I'll pick um, two values that are above the x coordinate, this one here. Okay, and two values that are below the x coordinate. So my table value is going to look something like this. So this is my x, right? So I said I'll pick 2 below the x coordinate, 2 above. So my 0 is here, which is the x coordinate of a turning point, right? So I'll pick two numbers below this x coordinate of a turning point. So I can pick -1 and -2. But it doesn't always have to be this, but these are just easy to work with. So you can pick any. And then here I have 1 and 2. Okay, and then from this table of values, I can find the corresponding y values using my equation here. Okay, so if my x is -2, I'll put -2 there. So it will be -2 squared, that will give me 4, plus this 2, this will give me what? 6. So I'll put 6 there. Okay, so these will be my y values. If My x is -1, it will be -1 squared plus 2. This will just be what? 3. If my x is 0, okay, it will be 0 squared, which is 0 plus 2, that will be 2. And if it is 1, it's going to give me back the 3. If it's 2, it's going to give me back the 6. So this is the table of values that they are talking about. Okay, so it's very important you follow the question the way they have said. So we have a turning point at 0, 2, which is this part here, 0, 2, and then we have all these other points. So we can plot them, and then we sketch this quadratic equation. Okay, so we're going to say, yeah, what's happening to my drawing ability? So, eh, eh, okay, so we have the y-axis, forgive my drawing. So this here is y, and then this one here is what? X. Okay, so 0, 1, 2, -1, -2. Okay, so this is what I have. And then let's plot whatever we have. So we have 0, 2, 0, 2. I forgot to label the y-axis. So you can say 2 is there, 4, and then 6, and the same down there. But we're not even going to use the points down. So the first plot was 0, 2. 0, 2 is here. So I plot there. Then -1, 3. So -1, 3. 3 should be between 2 and 4. So it should be somewhere there. Okay. -2, 6 should be somewhere here. Okay. And then this one, it will be 1, 3. So it's somewhere there. And then this one, 2, 6. So it will be somewhere there. Okay, so you've seen these points that we've plotted. Okay, we just now have to connect them with a what? With a smooth curve. So forgive my drawing, but I know you guys can do a better job. Okay, I was never an artist, so you just pass a smooth curve through these points like that. Yay. My drawing ability is running away from me. So like that. Okay, so this curve that we've drawn here is our y is equals to x squared plus what? 2. Okay, so this is actually one of the way in which we can sketch. So the one was asking, how do we sketch? This is how we can sketch a quadratic function. Okay, but we'll still look at how to sketch all those other functions. Okay, so now that we have sketched the graph of this quadratic function here, okay, we'll be required to state the domains and the range for which the function is restricted to become a one-to-one function. Okay, so the way we have drawn it, this graph here, is not one-to-one, because if I draw any horizontal line here, it will touch this graph at 2 points like that. Okay, so we have to restrict the domain so as to make it one-to-one. So the way it is here, it means the domain is coming from -infinity, because this graph will continue going like this. It will be reducing in the x values like that. And then even this one, as it goes up, it will also be going this side. It will go to positive infinity. So the domain, okay, just the way it is here, the domain is from -infinity all the way to positive infinity. This is the domain. So now I want to restrict the domain such that this function becomes a one-to-one function. Okay, so what are we going to do there? We are going to divide this graph, okay, into 2 parts. Okay, so how do you divide it? You just divide it at the turning point, okay? The turning point. So the turning point, we can see it's here. This is 0, 2. That's the turning point, right? So if I just draw a part of this graph or a part of this graph, then it means that I've restricted the domain. So I'll start with this part here. So the other part, if I can just draw a rough sketch of the graph that will remain, okay, if this is my 2 here, the graph that will remain will be this one here. So starting at 2, going like this. So just this part of the graph here. Okay, so we have restricted the domain here. So it means the domain here will be, okay, from -infinity all the way to here. So here we know that that is 0. So this the restricted domain, that makes this function to be a one-to-one. Okay, on the left side, it will be that the domain starts from -infinity all the way to what? To 0, like this. Okay, so this will be the restricted domain for this. And then the range, okay, the range, we should not worry about the range. It's always the same, whether you restrict the domain or you don't. So the range are the y values, okay? Remember, the domain are the x values. So we are looking at how far does it go, okay? How far does the function go horizontally? So here it goes all the way to minus infinity, and then it starts at 0. So the domain is from minus infinity to 0. So the range are the y values. So what is the lowest point in terms of the y's? So we are moving now in a vertical direction here. So the lowest point is 2. And then as it goes like this, it's increasing the value. So it means when I come here, it will be a value that is above 2. Okay? When I come there, still a value that is above 2. When I come there, still a value that is above 2. So wherever this graph is going like this, okay, it will be approaching positive infinity. So it means my range will be from 2 all the way to what? Positive infinity. Okay, so this will be my range, and then this will be my restricted domain, such that this graph here is a one-to-one what function. So we see that if we draw any horizontal line here, it's just going to be touching this curve at one point like that. So that means it's one-to-one, and we've restricted the domain. This is the restricted domain. So that was the first part. Okay. No wonder here they said state the domains. So this is the first domain, the range is the same. And then for the other part, it's going to be like this. Okay, so that is my y, and then this is my x. Forgot to label these. So if my 2 is there, so we just considered this one at first. So now we are considering this part here. Okay, that part. So it means if this is my 2, then my graph goes like this. Okay, so we see that the domain here will be what? Okay, I'm starting at 0 and I'm approaching what? Positive infinity here. So my restricted domain in this case, that makes this part to be one-to-one, will just be from 0, okay, all the way to positive infinity like that. So that will be the domain for this one. But the range still remains the same because the lowest point is 2. As it increases here, when I come to the y-axis, I'll be finding values that are greater than 2. So it will be from 2 all the way to what? Positive infinity. That will be my range there. Okay, so we have stated the two domains. There's this one, okay, and this one. And on both this graph and this graph, we see that it is a one-to-one function because when I draw a horizontal line like that, it only touches this at one point. Okay, so we are done with this first question here. Okay. Okay, so any questions there on what we've done? Are we following all of us? Okay, so silence means there's no question. Let's try to look at the second one, this one here. Okay, so I will erase this. So the second one, okay, let's first find the vertex or the turning point. So it is y is equals to minus 1 x minus 3 squared. Okay, so let's try to put this in this standard form. So it will be minus 1 the way it is, x minus 3 squared, and then plus 0. Okay, so this 0 here is the k. The h is the minus, the h is the 3, okay? And then this a is this minus 1. So it means our turning point is what? Okay, our turning point is just the h, which is 3, comma, the k, which is outside here, which is 0. Okay, I'm sure we're together there. And then we're going to do a similar thing that we did. Okay, I said we look at the, what now? Okay, we look at the x coordinate here, okay? And then we try to pick values, okay, below it and even uh, above it, okay? So in this case, let's do this. Okay, so I'll pick maybe 3 below and then 2 above, or it can be any. So this is my x, okay? The x coordinate of a turning point is 3, and then I have my y, right? So I'll set 2, or maybe let me just say 3 values below, and then 2 above it. So it means this one will be here. So if my x is 3, my y is 0. And then I pick 3 values below it, and then 2 values above it. So what am I going to pick? If this is 3, then this one should be 2, 1, and 0. And then this one should be 4 and 5. Okay? And then now we use this equation here to find the corresponding values for the y's here. So if my x is 0, what I'm going to have is y is equals to minus 1, 0 minus 3 squared. So this will be minus 1. And then this will just give me what? Here it will give me minus 3 squared, which is just positive 9. And then the positive 9 multiplied by minus 1, I get minus 9. So this here will be minus 9. Okay. What if I put 1 there? Okay. So you can try to put it there and then you juggle the thing. Okay, but what you're going to get is a -4. If you put 2, you're going to get -1. If you put 4, you're going to get -1. If you put 5, you're going to get -4. Okay, and then now we plot these points to sketch this guy here. Okay, okay, so let's do that. Okay, since my drawing is bad, I'm going to call upon Uncle Ruler. So let's get a rule here. So this one here, so that we draw straight lines. Huh, nice. So this is my Y, this is my X. Okay, so let's just plot whatever we have, or maybe we move this X-axis a bit because I can see negative values. So I'm going to put it there. Okay, so this is my Y, and this is my what? My X. Okay, okay, okay. Okay, so I can only see positive X values. So maybe let me draw it like this. Okay, and then like that. Okay, this will be better, I think. Okay, so just look at the pattern that the numbers are going to form, and then you can decide which one is a better sketch. So I have 0, I have 1, I have 2, I have 3, I have 4, and I have what? 5. Okay, and then here I'm going to put in the 2's. So this will be -2, -4, -6, -8, -10. Okay, so I'll start with the 0. So 0, comma -9. So -9 should be between -8 and -10. So it's there. Okay, that's my 0, comma this. 1, comma -4 should be somewhere there. Okay, maybe I didn't draw it properly. So 4 should be somewhere there. Okay, and then 2, comma -1. So -1 is between 0 and -2. So somewhere there. So that will be my 2, comma -1. And then 3, comma 0 is this guy. 4, comma -1 to be this guy. 5, comma -4 to be somewhere there. Okay, so if I had a 6 here, to be 6, it will be -9 like that. So it will just be that quadratic equation that you can see now. So we now just join these two more points here with a smooth curve like that. But I know you guys can draw better like that. Okay, so this curve in white, it will be my y is equals to minus x minus 3 squared. Okay, so now having sketched this graph, okay, we have to state the domains and the range for which the function is restricted to become a one-to-one. Okay, so how do we find those domains? We said we simply divide this graph into two parts. Okay, so where do we divide it from? We divide it at a turning point. So remember the turning point was this 3, 0. Okay, so at 3, 0 here, you can even draw a line if you want. So let's do this. Okay, so I'll draw a line here. This is 3, 0 there. Okay, so this line in some literature they call it as the symmetric line. Okay, divide this quadratic equation into two equal parts. Okay, so you can see what I've divided it into part. There's this part that starts from 3 going all the way this side. Okay, and there's this part that starts from 3 going the way this side. Okay, so if I pick just this graph here, this one, hey, what's happening now? Okay, if I pick okay, just a minute. If I pick this graph here, we see that, okay, it will be a one-to-one function because when I draw a horizontal line like that, just touch it at one point, okay? If I consider the whole graph like this, it means it won't be one-to-one because it will be touching here and touching there on the same graph, okay? But when I restrict it, when I just get this part, when I draw a vertical line, it will be one-to-one. Same as if I consider this part here, okay? It will also be a one-to-one. So now let's take the domain of this part and the domain of this part, but the range remains the same, okay? So let's do that. So I'll draw two new graphs, okay, based on the restricted domains. So let's just erase this part. Okay, so the first one will be in this form. I'll just be drawing to my small graphs. So this is my X, this is my Y, right? Okay, so I have 3 somewhere there. So I can start with this part here. Okay, so that part starts from 3 and then goes like this. Okay, right, so let's state the domain here. Okay, so the domain for this part here is, okay, so domain will just be, so this graph as it goes down here, it's also moving towards the left like this. Okay, so wherever it's going there, it will start approaching minus infinity. So it's coming from minus infinity as it is going down here, it's also moving to the left. Okay, so it's starting from minus infinity all the way to what? To 3. Okay, and then what is the range? So the range, we say that the y values, right? So the y values, you see that the highest is 3, and then it goes down. So it means it starts from minus infinity, and then all the way to what? Positive, um, uh, all the way to 0. Okay, not 3, in fact, all the way to 0, because here, the y value here in the x-axis, it's 0. So this line here, the x-axis, it's y is equals to 0. So the y will be from wherever it's coming from minus infinity, all the way to this line, which is what? 0. So that is the range, okay, of this first part. We can also find the range of the second part. So this is my y, and then this is my x, okay? So I have my 0 there and then my 3. So the other part now of the graph is this one. So it starts from here and then it goes like this, okay? So what is the domain for this? Okay, so the domain for this guy will be, okay, it's the domain, remember, we are considering the x values. So it's starting at 3, and then it's going all the way to positive infinity, because as it is going down here, it's also moving to the right, okay? So the domain will be from 3 all the way to what? Positive 3. Positive infinity, I mean. That will be the domain. And then the range won't change, okay? Because we're still considering the highest point of y and where it's going. So as it is going down there, it's going to minus infinity. Okay. And then the highest value is in this x-axis, which is y is equals to 0. So that will be my 0 there. Okay. So the range doesn't change, but the domain does change when you restrict it, depending on the side where you are. So on the left-hand side, the domain is this. On the right-hand side, the domain is this. And we see that this function now that we formed, if we draw a vertical, a horizontal line, I mean, it will start it at one point like that. So this means that this function now is one-to-one, and we have restricted the what? The domain. Okay, so that's it here. Okay, so any questions there on how we have sketched this one? Okay, so if there are no questions, let's move on to the next one. Okay, so this one here will be the last one that I'm solving here, because all these here, you do the same things that we are doing. Okay, so the other ones, you try them out, and then you can send your solutions to my inbox. Okay, you can send your solutions to my inbox. I'll be able to guide what you're doing is correct, or you need some improvements there and there. So let's do 3, and then the others here, you can try them out. Okay, so I'm going to erase this now. Okay, so 3 is equals to x plus 1 squared minus 4. So this one here is already in this form. So there's nothing that we are doing to it. We are just getting the turning point. So the turning point, we said we have to equate this x plus 1 to 0, and then we solve for x. So that will be minus 1. So this will be minus 1, comma. And then the y coordinate, we just get whatever is outside there. Okay, so we get minus 4. So the turning point is minus 1 minus 4. Okay, minus 1 minus 4. So that would mean what now? Okay, so minus 1 is our x coordinate of a turning point, right? So remember our trick, we're getting 2 points above it, 2 points below it. And then we use this equation to find the corresponding y. And then now we can plot. So let's draw our table of values here. So this is my x, this is my y. Okay, so I'll get 2 points below the minus 1, and then 2 points above it. Okay, so I'll put my minus 1 there. And then if this is minus 1, then what should this be? Okay, that should just be minus 2, then minus 3. This is minus 1. This one here should be 0 and 1. Okay, so those who are experiencing network challenges, I'm going to upload the video, don't worry. You're going to access the recorded video. So these are my x values that I've picked, okay? So now I use this equation here to find the corresponding y values here, and then we can use them to sketch. Okay, so let's use the equation here. So if my x is minus 3, then our y is equals to minus 3 plus 1 squared minus 2. So this is what I have, right? Okay, so this one here will just be minus 2 squared minus 4. So it will be 4 minus 4. Okay, to be 4 minus 4. So if my x is minus 3, then it means my y is 0. Okay, so you can do the same for all these others. You just place where there's x there, you put this value of x, and then you find the corresponding y. So if you put -2, okay, you have to find -3. If you put -1, you're going to find -4. If you put 0 there, okay, if you put 0, you're going to find -3. And then if you put 1, you're going to find, what are you going to find? Okay, if you put 1, you're going to find 0 again. Okay, so that's the pattern there. We've seen it. So let's use this now to sketch. Okay, let's use it to sketch. So let me draw my straight lines. So here I can see I have on the x I have negatives, and then there's some positive, and then on the y I have negatives. Okay, so let's draw something like this. So this is my y. Okay, and then this should be my x there. Okay, should be my x there. Okay, so this is my x, this is my y. So 0. Okay, on the y, I have -1, -2, -3, -4, -5. On the x, I have 0, 1, 2. On the other side, I have -1, -2, -3. So now I can plot whatever I have. So I have 3, -3, comma 0, I mean. So this will be this point. Okay. And then the other one is -2 minus -2. -2, comma -3. So this is -2, comma -3. So we are there. Okay. And then -1, comma -4. We are there. Okay. And then 0, comma -3. So it means I'm there. And then 1, comma 0, it means I'm there. Okay. So it means my curve will just pass through these two my green dots here. Okay. So we're going to draw a smooth curve that passes through those, then comes like that. Okay. So this one here will be my y is equals to x plus 1 squared minus 4. And we're done. Okay, so any questions on how we are graphing these things using a table of values? Any questions there? Okay, so now that we have sketched this quadratic function, okay, let us state the domains and the range for which the function is restricted to become a one-to-one function. Okay, so we have done this before on the previous two questions, so this one should not be a gamble. Okay, so what did we say? We said we just have to divide this graph into two equal parts, okay, at the what? The turning point. So we're going to go on the turning point, okay, and then we're going to draw a line. So the turning point was -1, comma, -4. So here, I'll just draw a straight line like that. Hey, what's happening? Okay, just draw a straight line here, like that. My line is not straight. Okay. Okay, this is bad. So this line, you've seen this red one, it divides this graph into two equal parts. There's this part that starts at here, okay? Starts there and then it goes to the right. There's also this part of the graph that starts from here, it goes to the left. So that's what it means to limit the domain, okay? Because the way it is here, the domain is from -infinity to +infinity. Because here, as it goes up, it's also decreasing in the x values. As it goes up here, it's also increasing in the x values. So here it goes to +infinity, here it goes to -infinity. So if we draw a horizontal line anywhere like that, to be touching this point, this curve at 2 points. So that means it's not one-to-one. So we want to make it one-to-one, so we limit the domain. So we cut there. Okay, so this is called the line of axis. Okay, the line of symmetry, I mean. So what we are going to do now is that we're going to separate these graphs. So the first graph will be something like this. Okay, so this is my -1, let this be my -4. So the first graph, okay, will start at this point, which is -1, comma, -4, and then it will go up, okay, it will go like that, passing at 1 there, okay? So here, what will be the domain? Okay, so remember the domain are the x values. So the x values here down, this is -1, and then it goes all the way to what? +infinity. So this would be -1 to +infinity. That would be the domain for this part. And then the range, we just look at the lowest y values and the highest. So the lowest y value is what? At -4 here. This is -4. So I'll say -4. And then the highest, it's going to what? Positive infinity, as it is increasing up there. Okay, it's increasing to positive infinity. So that will be my range for this first part of the graph. And then the other one to be like this. This is my x, this is my y. Okay, so let's plot it, the -1 there, then -4. So the other one will start at this point, okay, and then to go like that. So maybe I haven't drawn it properly. So let me erase some things here. Okay, so it goes like this. So it starts at here and then it goes like this. And then where it's cutting here, we saw that that was a -3, right? Okay, so now what will be the domain for this guy? So the domain, we're considering the x values, like in this way. Okay, so we see that as it is increasing up here, it's also decreasing in the x values. So it goes all the way to -infinity. Okay, and then here it ends at -1. So -1 like that. Okay, so that's the domain for this guy here. And then the range doesn't change. Okay, um, still remains -4 because that's the lowest point here. And then this thing is increasing there. It's increasing to what? Positive infinity like that. Okay, so this is the domain for this restricted uh, function. Even this is the domain for this restricted function. So we see that these functions now are now one-to-one. So because if I draw any horizontal line anywhere to just touch this thing at one point, anywhere, touch this thing at what? 1 point. Okay, so those are the um, domains and the ranges, okay, for the function if we restrict it to become one-to-one. Okay, so now let's look at question C. So on question C, we'll be finding the inverse or the inverses of all these functions that we've been given here. So now to find the inverse, okay, of a function, you have to make sure that that function is a one-to-one function. Okay, that's the only way in which you can find an inverse. Okay, so if, for example, a certain function is not one-to-one, okay, then we'll be required to limit the domain in some way so that we have the inverse for a certain part, which is one-to-one, and also the inverse of another part, which is what? One-to-one. So on all these we're first going to try to sketch them, okay? And then we use the horizontal line test to test if it's one-to-one. If it's one-to-one, we straight away find the inverse, okay? But if it's not one-to-one, okay, then we have to limit the domain in some way, and then now we find the inverse, okay, for those limited regions. So we start with the first one. So this one is f of x is equals to 2x plus 3, okay, 2x plus 3. So this is a linear function. So a linear function, definitely it's one-to-one, but we want to show it on a sketch, okay, we want to show it on a sketch. So we can create some table of values here. Okay, so we say this is my x, this is my y, and then we just use 3 points. So we put 0, -1, and 1. Okay, and then we draw the graph here somewhere. So this is my y-axis, and this is my x. Okay, so x and then y. So if my x is -2, -1, I mean, and then I put it in this function, what will be my y? So remember, y is the same as f of x. Okay, so we are using this function here. So if I put -1 there, it will be 2 -1 and then plus 3. So this will be -2 plus 3, which will just be what? 1. So if my x is -1, then my y is 1. Okay, what if I put 0 there? Then it will just be 2 multiplied by 0, which is 0, plus 3. Okay, so this will be 3. And then what if I put 1 there? Okay, then it will be 2 plus 3. So this will be 5. Okay, so we can plot these points here and then plot the straight line. So the first one is 0, and I mean -1, 1. So -1 can be somewhere there. I have my 1. Okay, and then 2, 3, 4, maybe 5 somewhere. Okay, here we have +1, I mean, there's 0. Okay, so we're saying -1 gives us a 1. Okay, so I'll plot there. And then 0 gives me a 3, so I'll plot there. Then 1 gives me a 5, so I plot there. So you can see the straight line there. So you just join these 3 points like that. Okay, so this is the line f of x is equals to 2x plus 3. So now we clearly see that this is one-to-one, because if I draw any horizontal line like this, okay, we see that the horizontal line will just be meeting this curve at one point. So we have confirmed that this is one-to-one. We can now find the what? The inverse, okay? So to find the inverse, we're going to say let f of x be y. So this is equals to 2x plus 3. And then here we just make x the subject of the formula. So I have y minus 3, okay, is equals to 2x. And then I divide both sides by 2. So it will be y minus 3 divided by 2 is equals to x. Okay. So once you make x the subject of the formula, okay, we are going to replace the x with the inverse function like that. So we replace this with this, and then the y, we replace it with the x. So we are going to have the inverse function, okay, just a minute. The inverse function of x is equals to this guy, where there is y now, I put back my x minus 3 over 2. Okay, so this one here will be my my inverse function, okay, for this guy here. Okay, so sometimes they can also ask you to actually state the domain and the range of the inverse function. Okay, so an easy way for finding the domain and the range of the inverse function is to know the domain and the range for the original function. So the original function, this one that we sketched here, we see that the domain is just the set of all real numbers. Okay, because this line as it goes here, it's also increasing in x, it's increasing in y. As it goes here, it's decreasing in y, decreasing in x. Okay, so the domain is all real numbers because this line will continue going like that. Okay, and then the range is also all real numbers. If you want, you can represent it as minus infinity to positive infinity. This is the domain of this. Even this one, okay, it's minus infinity to positive infinity because this line will continue growing in both directions, okay? So this is the domain and the range for the original function. So to find now the domain and the range for the inverse function, this one here, okay, we just swap the rows. The one which was the domain here becomes the range for this. The one which was the range here becomes the domain for this, okay? But here they're the same. So even if we swap them, there will be nothing. So the domain of this, there will be nothing changing even if we swap them. So the domain of this will still be the set of all real numbers, and the range will still be the set of all real numbers, okay? So maybe this example is not clear, but we'll get to see more as we solve these questions, okay? So that's how we can answer part one. Okay, so we found the inverse here. We've also stated the domain and the range. Okay, let's go to part two. Okay, so on part two, we have f of x is equals to x minus 1 squared. Okay, so is this function a one-to-one? Okay, so what we do is we try to sketch it. Okay, try to sketch this function. So this is my y, and then this is my x. Okay, so we're going to say, okay, let me label them. Okay, so this here, it's like a quadratic function that has been moved to the left by 1 unit. Okay, so later on, I'll teach you on how to sketch, okay, different functions. Okay, but here I'm just using them to know if it's one-to-one or not. Okay, so the uh the general quadratic equation or the simplest form is x squared. So the graph of x squared is the quadratic equation that has the turning point at 0, 0. So it comes like that. Yeah, what's happening to my drawing? It's coming like this, like that. So this is a graph of x squared. So now here we see that it is x minus 1. So meaning that this turning point has moved to the right by 1 unit. So how do I know that? You get whatever is in the brackets. So this is called graphing by transformation. You equate it to 0, and then you solve for x, which is 1. Okay, so it means the turning point has moved to the x1, but the y is still what? 0. So from this point, we know this is 0. Okay, it has moved 1 unit to the right. So it's somewhere here. Okay, so this is my 1 there. So the graph of whatever I have there will be this graph here. Okay, let me draw it smoothly. Turning point there, and then it goes like this. So this graph in blue is now my f of x is equals to x minus 1 squared. Okay, so we ask ourselves now, is this function one-to-one? Okay, so what do? We just try to draw a horizontal line anywhere like this. So we see that this horizontal line, or this one, they are meeting this blue curve at 2 points. Okay, so meaning this guy here is not 1-to-1, not 1-to-1. So if a function is not 1-to-1, then it doesn't have an inverse, okay? There's no inverse for it. So what do we do now to get some sort of an inverse? We have to limit the domain, okay? We limit the domain. So what we are going to do here, like in the previous questions, we are limiting the domain, you saw, when we are studying the domains on question B, okay? So we're going to cut here at the turning point like that. Okay, so this red line here has cut this blue curve into two parts. There's this one that is starting from here and then it's going like that, and then this one that starts from here and going like that. Okay, so now let's set the domain for this respective part here in blue. This one here up to 1, from 1 here, and then it's increasing like that. So for the domain for this, if we pick out the x values, okay, the domain for that part will be x is greater than or equal to what? 1. Like starting from here going like this, okay? X is greater than or equal to 1. And then here, if I start from here and then I go this, okay, it will be the domain should be x is less than or equal to 1 because it's coming from like minus infinity all the way to what? 1. And then it ends. If I consider this part, it's starting at 1 all the way to positive infinity. So we have limited the domains, okay? So meaning that when we find the inverse, there will be one inverse that will just be for this part here, where x is greater than 1. X is greater than or equal to 1. And there will also be a part of that inverse where x will be less than or equal to what? 1. Okay? All right. And then from there now we can get this equation. We replace our f of x with y. So we have x minus 1 squared. Okay, so we want to make x the subject. So what do? We see that there's a square here. So we're going to introduce the square root. Even this side, we're going to introduce a square root. So once we introduce a square root on this side, which does not have a square, we add plus or minus like that. Okay, so it means what we have is plus or minus the root of y is equals to this root and this square will cancel. So I remain with x minus 1. So meaning that my x is equals to, I take this negative 1 to the other side. So it will be 1 plus or minus what? Root of y. Okay, so it means our inverse here will just be, I replace this x with f inverse of x is equals to 1 plus or minus the root of what? X. So this is the form of, this is where we're going to get our inverses, okay? But those inverses will be strictly for the restricted what? Domain. Okay, so look at this now, okay? Look at this. So we had f of, we have f of x is equals to 1 plus or minus root of x. So before I changed it to this notation, it was x is equals to 1 plus or minus what? Root of y. Okay, so from this, we're going to get two expressions. Okay, so look at this. From this, we're going to get two expressions. Okay, from this. One will be that x, I'm using this one on top, is equals to 1 plus the root of y. Okay, the other one will be x is equals to 1 minus the root of y. So now look at these restricted domains. So for this part here, we said x should be greater than or equal to 1. So between these two equations here, where will the x be greater than or equal to 1? Okay, we see that it will be in the first equation here. Because here I'm saying x is equals to 1 plus the root of y. So I'm adding 1. I'm adding something to this 1 here. So it means the answer there for this x will be greater than or equal to 1 because I have 1 already and then I'm adding something. Okay, so it will be greater than or equal to 1. So if this is 0, it will be 1. But if it's any number, then the value of x will be what? Greater than 1. Okay, so it means this one here will be the inverse that will work if my restricted domain is this guy here. So I'll write x greater than or equal to 1. We'll work with this one here. And then if my restricted domain is this one where x is less than 1, okay, then we'll be using this second equation here. So look at this equation. It is x is equals to 1 minus something. So 1 minus something, it will make, definitely to make this guy to be less than 1. Okay, if it is 0, it will be equal to 1. But if it's, for example, this y is maybe 4, okay, it will be 1 minus 2, which will just be what? Minus 1. Minus 1 is less than 1. So meaning this restricted domain will work with this inverse here. So this one will be for the restricted domain where x is less than what? 1. Okay, and then now we can convert back to this notation. Okay, but before we convert that to this notation, remember I'd said from this graph here, okay, if we get the domain of this whole thing without restricting it, we're going to say the domain is a set of all real values without restricting it, okay, this blue line here. And then what will be the range? The range will be the lowest point of the y. So the lowest point, I go here, this is 0, and then it's increasing. So it means my range there is that y, okay, should be greater than or equal to what? To 0. Okay, so it means this inverse that I've found here, its domain, okay, this inverse that I'm finding, its domain will just be that the y is greater than or equal to 0, okay? Or in short, x is greater than or equal to 0 when we convert it back to the x variable. So I'll erase this, and then I'm going to write the two inverses that we have. So the first inverse, okay, the first inverse will be for the restricted domain. Okay, for the restricted domain, um, x is greater than 1. So it will be this guy here. So this one, I write it now in this notation, it will be f inverse is equals to 1 plus the root of what? X. But itself, this inverse, what is its domain? Okay, itself, this inverse, its domain is that x should be greater than or equal to what? To 0. From that y is greater than or equal to 0, which was the range for the original function. Here it becomes the domain. Okay, and then for the restricted, the other part, what would be the inverse? Okay, for the restricted x is less than or equal to 1. Okay, it means our function f of x will be 1 minus what? Root of x. Okay, so the domain for this function, which is the inverse, doesn't change. It will still be x greater than or equal to 0. But this one will only be working if we restrict our domain for the original function to be x is less than what? Less than or equal to 1. And then for x is greater than or equal to 1, it will be this. So we have two inverses, okay? If we restrict the domain to be this will be our inverse. If we restrict the domain to be this will be our inverse. Okay, so we are done with that one. Okay, so let's look at part 3, okay? So part 3 now, we have f of x is equals to the root of x plus 4. Okay, so the root of x plus 4, what is it graphically? Okay, so if we plot it on a graph, this is my y, and then this is my x. Okay, so this is just a radical function that has been shifted up by 4 units. Okay, so if I can draw another graph here, okay, so the typical graph of f of x, or we can say y, is equals to root of x. It's just a graph that starts at 0, 0, and then it goes like this. Okay, so this is the graph of root of x, this one here. So now this graph has been shifted up by what? 4 units here, these 4 units. So it means from 0, it has moved up to 4 like that. So it will be the graph that goes like this. So here I'll say this is 4. So from 4, and then the graph goes like this. So this is the graph of this function. Okay, so from this graph, what will be the domain of this same original graph? Okay, the domain, remember the x values. So the x values are starting at what? This is at 0. 0 going this side. Okay, so the domain here is that x should be greater than or equal to 0. Or if you want to write it in certain interval notation, okay, it will be 0 to positive infinity like that. And then what will be the range? The range are the y values. So the lowest y value is 4. And then as it increases here, okay, it means the y value will also be increasing, right? So it means my y should be greater than or equal to what? 4. Or here, why have I written 0? Okay, should be greater than or equal to 4. And then here, it means I have 4 to positive infinity in interval notation. Okay, so this will be the domain and the range for this function. And then now we can find our inverse. Okay, so let's find our inverse. So our inverse, we're going to let this f of x be equals to y, and then root of x plus 4. So meaning that I have root of x is equals to y minus 4. Okay, and then from here, what I'm going to do is that I'm going to square both sides. Even this side I square. So if I square, okay, it means to cancel out with this like that. So it will be x is equals to y minus 4 squared. So this will just give me the inverse to be the inverse of x is equals to, where there's y, we now put back our x minus 4 and then squared. Okay, so this will be the inverse, but what will be the domain and the range for this inverse? Okay, so remember, the domain for the original function is the range for the inverse. The range of the original function, okay, is the domain for the what? For the inverse. So for this guy, the inverse that we found, the domain will be Okay, the domain looks at the x values. Okay, so this one here will be the domain, which was the range for the original function. So I'm going to say my domain is just 4. Okay, and then the range will be the domain of the original function, which was 0 to what? To positive infinity. Okay, so this is our inverse, and it works on this domain and this range. Okay, we go to 4. Okay, so I'm drawing the graphs there so that we can easily see what we are doing. So 4, we have f of x is equals to 3e to the power 2x. Okay, so how does the sketch of this guy look like? Okay, so the sketch of this guy is not even difficult. Okay, so the standard sketch for e power x is the sketch, okay, that has a vertical, it has a horizontal asymptote in the x-axis like that. Okay, and then, okay, so this is f of x or y is equals to e power x, right? So I want to sketch this. So this one, okay, you get the power, you equate it to 0 and then solve for x. So this one will give you the horizontal asymptote, which is this dotted line that I've put there on top of the x-axis. Okay, so this will be my horizontal asymptote. And then what else do you need to get? You need to get your y-intercept. So to find your y-intercept, then you say my x should be what? 0. So where there's x there, I put 0. Y will be equals to e to the power 0, which is just what? 1. So my y-intercept will be at 1. In short, it will be at 0, 0.1. So 0, 0.1 will be like that. So every e power something always has the shape that goes like this. This is the graph. Okay. So now to this e power something, we have added a 2 in front, like this one, and we have also added a 3 here. So does that change anything in terms of how the graph is going to look like? No. Okay. Because to find the vertical asymptote, we said we equate whatever the power is here to 0. So if I equate 2x, which is this one, to 0, and then so for x, I'm still going to find 0. So it means my horizontal asymptote is still the x-axis like that. Okay. And then if I put, okay, I see, it actually changes the y-intercept. If now I want to find the y-intercept, it will be f of 0 is equals to 3e to 0 like this. So this will just be 3e to the power 0, which is just what? 3. Okay. So it means y is equals to 3 will be my y-intercept. So it will pass at somewhere 3 here. So it will be a graph that goes like this. Okay, so what is the domain now? So this is the original function. We haven't even found the inverse. So the domain here, we see that in terms of x, it's coming all the way from minus infinity, going to positive infinity. So the domain is all real numbers. Okay, or we can write it in set interval notation. We can say from minus infinity all the way to positive infinity. Okay, and then the range, still the same. No. The range, the lowest y value, okay, it's approaching this 0 or the x-axis. So it's starting at 0 and then it's going to positive infinity. Okay, because the y values, it will be here. This is approaching 0 and then it's going up like that until positive infinity. Okay, so now let's find the inverse. Okay, so it means for the inverse, the domain will just be this range here. And then the range will just be this domain. So we'll set our f of x to be equals to y. Then we have 3e to the power 2x. Okay. And then from here, we're going to say what? We're going to say, okay, we're going to say, let's make x the subject of the formula. So I divide, first of all, both sides by 3. So I remain with 2 e power 2x is equals to, if I divide by 3, I have y over 3. Okay, and then from here, I want to make x the subject. So what do? I introduce ln. Even this side, I introduce ln because I have e power something there. Okay, we know that ln is the same as log e. Okay, so what we have, or what this allows us to do, is that it allows us to drop this power. So this power drops here. So it will be 2x ln e is equals to ln of y over 3. So ln e is the same as 1, okay? Because this ln is just log to base e and then e. So if the base and the follow-up number is the same, this is always 1, okay? So meaning that if you have log 5, 5, this is 1. As long as these two numbers are the same, it will be equals to 1. So this is 1. So I just remain with 2x is equals to this. So it means x will just be equals to, okay, ln y over 3 divided by 2. Okay, but ln y over 2 is the same as ln y minus ln 3 divided by 2, x. Okay, so that would be our inverse there. So let's write it properly now. So our inverse will just be f inverse of x will be equals to ln y minus ln 3 over 2. Okay, so what will be the domain of this inverse function? We just get the range of the original function, which is 0 to positive infinity. And then what will be the domain? What would be the range of this inverse function? To just be the domain of the original function, which was minus infinity to positive infinity. And we are done with finding the what? The inverse of this function. Okay, now we look at question 5. Okay, so question 5, this one, this one, this one, and this one, we handle them the same way. Okay, so I'm just going to solve this one and maybe this one. Okay, and then this one, you can try it out on your own. Okay, so let's do that. Okay, so here we have f of x is equals to ln x minus 5. So the graph of ln x, okay, the standard graph of y is equals to ln x, like this, okay? It's just a graph that passes at the point 1, 0. So this is 1, 0 here. So it will have a vertical asymptote as the y-axis, okay? So remember, for the power, or e power something, we said the asymptote was the x-axis. So if you go to the opposite now to the logs or the lins, okay, the asymptote becomes the y-axis like that. So this graph here for ln x, just be a graph that does not touch the y-axis and then it passes through 1, 0 like that. So this is ln x, okay? But now here it has been shifted 5 units to the right. Okay, so how do I know that? You get 5 minus x minus 5, is equals to 0. And then you solve for x. So it means it has been shifted 5 units to the right. So it means this point, which is at 1 here, goes to the point 5. Okay? And then it means the the vertical, this vertical asymptote also follows. Okay? So this vertical asymptote was at x is equals to 0, right? And then this intercept was at 1. So if this intercept has gone to 5, then the vertical asymptote has to go at 4. Okay, so if this is 4, it will become the vertical asymptote. And then we have this graph like that. Okay, so now let's draw it nicely here. So don't worry about the sketching. We're also going to learn about how to sketch them one by one. Okay, but here I'm just using them so that it is easier for us to know if it's one-to-one or it's not. So here we say this is 4, and then this is 5. So we've said this guy here becomes our vertical asymptote, and then our graph will be a line that passes through 5, 0 here. Okay, so what will be the domain of this guy? The domain is the x values. So this graph here is going closer and closer to the 4, but it never touches it. So it is from 4 all the way to positive infinity, the domain. And then the range, okay, is from minus infinity all the way to positive infinity, because this one goes to minus infinity, this one goes to positive infinity. So minus infinity, positive infinity. Okay, so this domain will be the range for the inverse. This range will be the domain for the inverse. So now let's find our inverse function. Okay, so our inverse function, we're going to set this f of x to y is equals to ln x minus 5. Okay, so how do we solve this? We introduce e power something on both sides like this. So here I have e power y is equals to, here I'll just remain with x minus 5. So now you'll be wondering what magic is happening. Okay, what magic? There's no magic that is happening. So when you look at the properties of the logs, we said if I have a to the power log of the base a and then b, this here is the same as b. Okay, so if I have a there to the power log that has the base a, and then I have something here, it's just the same as something. So this log and this power will cancel out. So that's what we've done here. Because this e to the power ln x minus 5, okay? Remember this ln here, okay? So I have, and then x minus 5, right? So this ln here, okay, I've stated it a number of times, the same as log e, and then x minus 5. So by this property here, this log e and the e will cancel out. So I just remain with x minus 5. So that is what happened there, okay? So from there now, we make x the subject. So it will just be what? E y plus 5 is equals to x, or simply x is equals to 5 plus e to the power y. Okay, and then we write it now as an inverse. It will be the inverse of x is equals to 5 plus e to the power what? X. Okay, so what will be the domain and the range for this inverse? Okay, we just said the domain will be the range for the original function. So the domain, okay, for the inverse is the same as the range for the original function. So the domain will be minus infinity to positive infinity. And then the range will be the domain of the original function. So it will be 4 plus like that. All right, so that's great. So it means you can try out this one. You can also try out this one because they are in the same format, right? Okay, so I'll look at this one and maybe that one. Then we'll be done with question 1. Okay, so let's do that. So now, okay, we have f of x is equals to 5x minus 1. Okay, 5x minus 1. So how can we find the inverse of this? Okay, so the first thing is to check if it's a one-to-one. So all the graphs that have been drawing there, okay, even there, if you use the horizontal line test, you see that it only touches it at one point, okay? But it was only here where we had some restrictions that we had to make. Okay, so what about this one here? So this one, this is y, this is the x, okay? So what are we going to do here? Okay, to sketch this guy. So if I have okay, if I have 5 to the power x, then the graph will just be the x-axis will be the vertical, it will be the horizontal asymptote, I mean. Okay, it will be the horizontal asymptote like that. And then this guy will pass at 1, 0 here. Okay, so now I have x minus I have x minus 5. Okay, yeah, I have 5 to the power x minus 1. Okay, so how do I sketch that one? Okay, how do I sketch that one? Okay, so what we are going to do here is this. Okay, so look closely what we are going to do. Okay, so this x minus y will just change the y-intercept. Okay, so for 5 to the power x, it will pass at 0, 1. But if it's 5 to the power x minus 1, then this intercept will change. Okay, so to find the y-intercept, we always set the x to be equals to 0. So I'm going to say y-intercept at f of 0 is equals to 5, 0 minus 1, which will just be 5 to the power minus 1, which will just be 1 over 5. So 1 over 5 is a number that is below 1. Okay, so this point moved to somewhere there. Okay, so now the graph of that will be this graph here, like that. So this will be the graph of 5x minus 1. Okay, so we can see that the domain here is clearly all real numbers. The range, okay, is from 0 all the way to positive infinity. Okay, so from there now we can find the inverse. So we see that all these graphs that have been drawing, even if I was not saying it, but if you draw a straight line like this, see that it's only touching it at one point. So they are one-to-one. Okay, no wonder we've been able to find the inverses. So let's find now. So this one is y is equals to 5x minus 1. Okay, and then I introduce ln on both sides. Maybe here we should even introduce a log that has a base 5 because I can see 5 here. So I'll say log of base 5, y is equals to log of base 5, 5x minus 1. Okay, so this is what I have here. So what this allows me is to drop this x minus 1 power in front. So it would be log base 5y is equals to x minus 1 and then log 5, 5. So remember I said if you have the same base as the number that follows, this becomes 1. Okay, so this is 1. So I just have now log base 5y is equals to x minus 1 because this is 1. Okay, so it means my x will just be equals to 1 plus log base 5y. Okay, we write it in terms of an inverse. Okay, it will be the inverse of x is equals to 1 plus log base 5x. Okay, what will be the domain of this? It will just be the range that we had here. So the domain here will be 0, positive infinity. And then the range will be minus infinity to positive infinity. Okay, so that's what we have there. And then let's look at the last question, which is this one. Okay, so the last question is just y is equals to e to the power x minus 4. Okay, so this one, even without drawing it, okay, you can try out the sketch, but it's still 1-to-1. Okay, so I can find my inverse. So say y plus 4 is equals to e to the power x. And then I want to make x the subject, and I can see e here. So I'll introduce ln, even this side ln. So this ln allows me to drop this x. So I have x ln e is equals to ln y plus 4. Okay, so this one becomes 1. Okay, that one becomes 1. So it's just x multiplied by 1, which is x is equals to ln 4 plus y. So we write it now as f inverse of x is equals to ln um, ln 4 plus x. Okay, so this is the inverse here. Then you can try to find its domain and the range. Okay, so we are done with question 1. Okay, so if there are no questions, I think for today we can actually end here. Okay, yeah, we can end here if there are no questions. But for those who are interested in our lessons, we actually have videos on all the other tutorial sheets, so you can access them on our website. Okay, so I can even show you the website right here. So what's happening now? Okay, so if you go on our websites, okay, once you register on your course, you register for this course math. It will write enrolled here once you subscribe. So you can open this course, and then once you're here, you go in general math. Okay. Here we have 4 folders. So in the first folder here, we have lessons and tutorials. So there we have lessons on each topic that you're going to learn. So like how to sketch quadratic functions. If you go here, you're going to find a folder, quadratic functions. Okay, you're going to find some well-written notes there that you can read, and also some videos about quadratic function. So you can watch them in this folder, lessons and tutorials. So you find topic lessons here. Okay, here they're just some handwritten summarized notes. Here there are past papers, here there are tutorial sheets. So as you prepare for your mid-semester exams, okay, we have videos on the tutorial sheet. And if you are able to solve all questions in the tutorial sheet, it will be very easy for you to pass. So if you open this folder, okay, if you're from what university is this? Unilus. So you find this folder for Unilus if you're from Unilus. So you open this folder for Unilus. Okay, so it's going to ask you first semester, second semester. You guys are in first semester, right? So you go in first semester there. And then here there are just lecture notes. Okay, here there are some written solutions to some of the tutorial sheets. And then here there are video solutions. So you want to go in the video solutions there. Okay, and then you go in your intake. So this is January 2025 intake. So you open here in the January 2025 intake. Okay, so you're going to find the videos on tutorial sheet. So tutorial sheet 1, we have 4 videos there. So you can watch these videos at your own time. You learn all the concepts before the mid-semester exam, even for the exam that you'll be preparing for. Tutorial sheet 2, we have 4 videos there. Okay, so if I can open it, tutorial sheet 2 was on exponentials and logarithms, right? So you can see question 1 up to 5. So there's a full video there. Okay, and then this one that we are solving was tutorial sheet 3. So we're also going to solve all the questions in tutorial sheet 3. We're going to upload them here, so you can access them at any time. Okay, tutorial sheet 5 was on what? Is it this is on discrete random variables, right? So all the questions in that tutorial sheet, we've already solved them. They're there. Question 4 is on the sequences and series. I've already solved them. All the videos are here. So you can actually learn at your own time. Okay, at your own pace. If you don't understand, just take back the video, you listen again, or you can actually contact me. Okay, you can just inbox me, you ask, then I'll be able to help you. Okay, so be free to, if you want to register, be free. Okay, I'll send a registration guide after this. When I upload the video, I'm going to send a registration guide. So those who are interested, you can actually register. You can also access some past papers. Okay, some past papers. You go to the past paper section. You pick your university, Unilus there. Okay, so you're going to find some videos here. Okay, for the past papers. So you go in the folder for videos, you're going to find them. Right, so I wanted to show you that. Otherwise, thank you so much for attending this one. Um, I'm going to solve all these other questions here. So if you'd like to access the videos to all these other questions, feel free to register with us. Okay, have a blessed night, guys.